Hello everyone. I'm Naveen and I want to demonstrate my project on MetaKaggle Hackathon. And Kaggle isn't a platform for data science competition. It is a living, breathing ecosystem of data, code, community. But what happens when we turn the lens inwards and analyze Kaggle itself? In our project, we have explored MetaKaggle datasets, the data about Kaggle, using a mix of analytical and statistical tools. This unique dataset includes information about users, kernels, dataset, competition, submission, forums, and many more. Our goal is to uncover the hidden patterns and deeper insights that define how Kaggle uh, community has shaped the progress of machine learning and AI over the time. From metadata to model code, we have examined 41 different dimensions of CSV files and various codes in IPNBY format and R and etc. In this video, I will walk you through the dominant trends and surprising discoveries and the evolution of this incredible AI ecosystem. Let's deep dive into what Kaggle own data tells about progress, collaboration, and future of AI itself. For this hackathon, we have made 7 notebooks, 2 datasets, and 1 write-up and submitted in the workups which is available here. And now let me go through my 7 notebooks and datasets which I have submitted in this hackathon, in this project. First is MetaKaggle. It consists of 41 CSV files of 42 GB size as listed here. And next, next we will go through the MetaKaggle code. These are the files which existed on Kaggle. Uh, and there are 5.97 million files which comprises of uh, notebooks, Python files, R, and etc. And as a resource, there is a notebook which is created by Paul Mooney, uh, which combines the both MetaKaggle and MetaKaggle code. We have used this also in this. Now let us deep dive into my first notebook, user demographics and forecast. In the this notebook consists of like user demographics, like which countries the most Kaggle users are present, and um, like growth trends of Kaggle users increases over the time. Uh, and at end, I have made a custom uh, LLM which explains the data set and which helps in the analysis also. And now for that only I have installed Grady application and I have deployed that LLM into the Gradio space. I have used Google AI Studios, Gemini 2.0 Flash. Uh, as these are our main parent data sets like MetaKaggle and MetaKaggle code, and we know that MetaKaggle consists of 41 CSV files. In that, we for now we are presently going. We will see the relationship between each data sets and the data overview. Uh, to get to know about more CSV files, I have printed the columns and stored in a HTML so that running takes a lot of time as it is 42 GB and processing takes a lot of time. So I have saved it. And first of all, the relationships. Um, I have made a picture for this like yeah diagram which depicts the relationship between two CSV files and using which column the CSV files are connected. For example, um, there is kernel languages and kernel version. In that, using script language ID, the kernel version is connected to the kernel languages and etc. You can find many more in this. And now let us deep dive into geographical breakdown of users, like which country consists of maximum users in the Kaggle platform. And we can see here like around 25 million columns rows are present in user CSV file. So this denotes that the around 25 million people or users are existed in the Kaggle platform. And now I want to see geographically, like how many people have not registered the country. You can register the country in your Kaggle profile. Like around 23 million do not register their location, which is a huge number. But I want to really go into which country the maximum users are present. So I will use the remaining which have filled the location. Like around 13 lakhs people are there. You can see like in this also like 273 countries are there, which is practically wrong. So like there are multiple same like USA is there. They have written the same name like USA in two times. Like you can see here USA one time and United States of America, and some names are not present. So we have to do a basic pre-processing at start. Mm, Like after doing some basic pre-processing and stuff and normalized it, some have changed um, some names accordingly, like India hyphen is there, like two hyphen, and added those all to India. And some members have registered like city names or state names like Rajasthan, which is a state of India. But we have to write like it is a we have to write country, right? So we have changed it like in initial pre-processing steps, we have changed it to India. And at last, we are using Folium and GeoJSON uh, data. We have got the locations respectively and changed the names according to the GeoJSON format. So at last, we have got the mm, breakdown of users across the globe, and which is surprisingly America, around 4 lakh people are present. Um, but I hope more users are from India because many members have not recorded their location as the population. It is one of the most population, or China may be the other country which will be in the top. So now we will go into the like growth of users by year. And we know that like around 25 million users are there in Kaggle till date. Uh, According to Wikipedia, 23 million uh, have registered till 31st March 2025. During the span of next 4 months, around 2 million have registered. See, like the first user is January 20th, 2010, and the latest user is 7/19, 2025, which is 2 days back to my date. Um, and next, like we tried to forecast like what can be the projected users in 2023, 2026, and 2025 using the three linear, exponential, and polynomial. Like you can see those projections here using linear forecast, exponential forecast, and uh, polynomial forecast. At end, we can say like at around 2026, there may be Around 60 million people have registered across Kaggle. Not 60, around 30. It's my, we are predicting like that. And next, like the LLM bot, which we have created, and I have deployed it to the Hugging Face. Now, and I have loaded here using the Gradio. Like interface is not running here because it is a uh, pre-run code. So you can see, like, you can ask the question here, like how many, how to users in Kaggle, and it will give you like a step-by-step process, like how to calculate the number of users. And this is my first notebook, and now let us go into the our second notebook. And now, in our second notebook, we will continue like the rest of the user analysis, and we will be decrypting datasets of the target, like how many datasets are present and what are the best datasets till date, and etc. And first, anyhow, we have to import our respective pattern libraries, which will be used. Like mainly, we have used Plotly, NumPy, and Pandas, and Colab, which is for importing data. And these are the datasets. First, like I want to test like some data sets like a like some user stats. I want to see like I'll presently check my user stats, like how the data set is working and all. Like my user name is this, so using that I have got my row, which is correct. And user organization, user followers, and user achievements. Like next three datasets I will be working on. Like user followers, I have checked like how many followers are there. Like I have 51 followers at till date. Uh, Now like we can see like total follow relationship, like how many followers are there and how many unique users follow others, like etc. Like you can see here unique user who follow others, like around 5 lakh followers, and unique users being followed are 2 lakh around. And now we can see the follower relationship trends, like I think around 2017, Kaggle has started this follow this thing. So from 2017 to 2025, the relationship is quite growing and it's not monotonical, like the trends are present. And you can see here like the most popular followed user, like the user 4476084. Uh, we will get into the who is this user. Like next, distribution followers per user and distribution of followings per user. You can see this here. See, like Jessie is the topmost with around 26,000 followers, which is the highest till date. She is an ex-Kaggle staff. And now user achievements, like in Kaggle there is a special gaming like system like medals and users, etc., which is quite popular. And now you will get into the use of the highest gold medals, like gold medals. The highest gold medals are 587. Recently discussions are removed as part of the gaming, like gaming system in this. Like They have removed grandmasters and all this stuff. But at least like 587 is a very good number. It's traceability. And we know like there are five tiers in Kaggle: novice, contributor, expert, master, grandmaster. And we will see like user organizations and like in which organizations like most users joined and like the you can see here like the organization trend. And next like we can see like organization 49 have near around 175 users in their organization which are registered in the Kaggle. Like the it is New York state, state of New York. And now let us go to like main part of this node. Like we will decode the data sets, like how many data sets created over the years. Like we know like at 2015 Kaggle have started the data sets, and at first there are around 10 data sets, and now around like 137K this last year have they have produced. Like many users have uploaded, and which is very popular. Like Kaggle datasets are very popular and very authentic. You can see like user engagement now, like how many users, like datasets they have viewed and total downloads, etc. Like you can see here, like the peak is like around 2020 with 193 million views, and which is the highest till date, like in the year 2020. And with a download of 21 million, the views will always be higher and downloads will be respectively low. And we have now we can see top voted dataset, and I, I can find like the top voted dataset on Kaggle and top viewed, downloaded, and top kernels created using the dataset.csv file. Um, and for to view the name, we need dataset versions also. So like let me show you how I got. Like the highest kernels created, which is a popular data set like iris species. Like it is a basic start for machine learning. So highest kernels will be created here only. And top voted data set on Kaggle, that is Animal Crossing dataset, and top viewed and top downloaded dataset like is credit card fraud detection, which is like basic classification problem. And you can see here like download to view efficiency, like total downloads by total views. Over the years 2015 to 25, you can see like the bottom will be around 2020 because it's have the highest views around 20 million. And now we have seen like the top views. Now yearly data set versioning trends, like it is similar to around datasets. Like here we can in Kaggle, which is a best feature, like we can create versions. Like we can save our progress and run it. And later, if you want to update the dataset, it will save into the new version. Like they told you that versions they have more versions are created across the year, which will be in similar trend to the datasets created. And like Kaggle also like provides like a tag for licenses. Like licensing is main to stop like plagiarism and etc. Then like generally main licensing is like CC and etc. And Apache is also widely used. And you can see like the trends over the year of license usage and heaviest data till record, like highest data set which is available on Kaggle. It is the GDELT, and the organization which created it GDELT project. And the popular tags in the dataset, like later I have created all tags in OnePlus, like for the initial, like how these tags and everything is working. So I have tested here, and like I have done like top 15 best tags used in datasets in Kaggle. Like the top 15 tags which used here are pre-trained models and business and etc. You can see the graph here. Like the top is like by the count it is like pre-trained models and business. You can see here low is business, like the top is business and the next is pre-trained models and every top 10 here. And now tasks associated with data sets and submission. Uh, like in 3 years, like around 2019 to 2021, uh, like Kaggle have released a new feature, I think. Like, there will be we can create a data set and we can create a task for it where many other users can submit their tasks for the data set. It is like a competition, but it's not a competition. Uh, like 3 years I have told it, like they have tried this feature around 264, 264 on the initial year, and on the final which they have stopped like 2671 datasets they have created datasets with us, and the submission is also on the similar trend, like around 68 submission on the first, and at that last 5114 submissions are present. And now voting behavior on Kaggle, like we can vote across like main three datasets, kernels and competitions. Like I have made a pie and bar, the pie looks better. And you can see like the highest trend is on 2022, like highest votes got on all data sets is on 2022 with a count of 4 lakhs. And similarly, I have created some kernels also, but there is a problem like a bug in the MetaKaggle code. The data set got erased or something, but I have already run previously around 1 month back. At the time, the dataset is available, and the highest votes on kernels is like 2024 with 22%, and at last, like models, the recent at 2023 they have created the models. Then the distribution is like fairly large in 2024 as the 2025 is going on. Next, we will go into the next notebook. Now our third notebook is like kernel crux, like important parts of kernels like accelerator languages and etc. We have done analysis here, and now like importing our libraries which we have used here the dataset, and we will be using the main dataset like kernels and kernel versions. We will see like kernel growth over the year, like it is like similar trend to the datasets. First, like around 77,000 kernels are at 2025 and around 3 million at 2024, and present till date, like July 21st, 1.8 million kernels are present. I hope it goes above. 3 million. Mhm. Now, like I told, right, like accelerator breakdown, like in the main thing in kernel, like which accelerator generally people use, like generally many people use like CPU, like it is no need to go to like settings and change the accelerator to another GPUs. Like there are two free like GPUs for 30 hours a week in Kaggle, like GPU 300 and GPU T4 cost two. Mm, but there are many types of GPUs available on Kaggle. Like there are 11 types with CPU included, and the count respectively for each type is given in this table, and the count like number of card like CPU in 2015 used around 12,000. Like I have made a table for that also to plot the graph, like uh, like around 1.3 million notebooks with CPU users, and around 133K GPU P100 is used, and remaining is as stated here. And you can see here like there are many GPUs, but these are very rarely used and previously used. The mainly used is CPU, GPU P4 and GPU P100. And at 2014, T4 is used around 15K and 17K for GPU P100, which are a good accelerator for deep learning purposes and for pre-training and etc. And now like running time of a kernel, like how much time like a kernel takes is also present in kernel versions. CSV, like we can see like here I have made a box plot which will get an median, mean and exam for or kernels, and like how much time you run on an average, like etc. You can see like around 22 seconds for normal CPU. Like there are highest like around 12 hours CPU is run, but you can see like on an average like around 13 million, 1.3 million files, like only some around like 5 seconds, 10 seconds, etc. So the average is 22 seconds, whereas GPUs used here are somewhat more. Like here, like generally, many people use GPU for their high computational purpose, like deep learning, image processing, and etc. So the average generally, like for this, if the CPU is run on this, it will like take long heck of a time. But GPU gives us a resource and which reduces the running time of the kernel. And you can see here the average running time of by year. Like you can see like 2016, like 2026, you can see like 16,000 seconds like average running time. It's because like in 2050, 2025, many people are running like transformers and related, which are high computing. So the you can see like the trend goes on increasing, like in between like deep learning is mainly used, and so again like the rise of GPUs also happened, so the computation speed decreased in the between. You and like the chart like distribution of like with GPUs, and around 86% like the usage or use of CPUs in kernels. And now like languages, kernel languages, like there are like Kaggle supports two languages, R and Python. And in Python also we can run scripts like in we can store it in a data set, and we can import and we can run using an input like, and again we can normally run a Python script and R script. And but mainly many people use Kaggle for notebooks, which is a best cloud for running Kaggle notebooks, You can see, and we can see like Python and R, like which language is mostly used. Like in Kaggle, the mostly used is Python, around 14 million files for Python and 866K for R, which is a huge difference. And like here, I have cleaned the like memory, like that here the kernel versions take too much of memory, so I have cleared the memory and so like all kernels will be on one place. So and next, like the kernel versions data sources is another CSV file. Like you can see here like which data set is used. Suppose example for this, you can see like you can see here like data sets which they have used. Like these are the data set sources. Like that for many kernels there will be data set sources. So to we need to do an analysis for that also. So I have made an like like how many kernels are used using dataset in Kaggle, like over like growth trend is also present, and the top dataset which is top datasets which is used and its trend. Like you can see like the iris which is the first step towards the ML, like it using like consistently over the years. And around 2021 there is a like one data set like fitness tracker data, a fitness Fitbit, like it's used it the most around 21 to 24. But as Iris is the top, like consistent, it maintains consistency here, the count. Now, generally, the most popularly the dataset is hot when like more usage comes when the dataset is early, like when the dataset is 1 month, like the usage is around like 3.5 into 10 power 6. Whereas where the months go on, like the dataset usage decreases in Kaggle. And like the which language is used, like here Python is main, and in language it means it's Markdown, I think. So notebook, I think, like C, like IPYNV. And now dataset reuse percentage, like how many members are reusing the dataset. You can see the growth trend here, and like in which month the datasets are using, like kernels uses most dataset, like it's according to her analysis, like April and May are the peak where the datas are used. And you can see like the top 10 most used datasets like fitness bit, iris, chest x-ray. Like this is also one of the basic for deep learning and credit card for everything. Like and next, similarly, like how data sets are used, we can use models on Kaggle, like from 2023, like we can use models, and now Kaggle have integrated Hugging Face also here. So we can easily use models here. Like we can give a trend like which framework is mostly used. And like here we can see like transformers is second, and like first is like PyTorch, and which is a main. And next, like which organization like kernels, like which organization to that model belong. Like mainly they are like in these two organizations, TIM and TensorFlow. TensorFlow is relatively high because it's like one of the oldest. So many old models are in TensorFlow. Recently, TIM is highly used, like it is PyTorch for computer vision models. And now, similarly, how the licenses are available for datasets. Similarly, models also consist of license, but there are mainly three. three used licenses, which are Apache 2.0, Gamma, and MIT. Apache is the highest, and again clean the memory. And next we will see how many members have forking the notebooks. And now Kaggle also recently added a new feature. If anybody forks their data set, they will get a new upvote, which increases the upvote and visibility of that notebook, which also helps in recognition of that notebook by an upvote. Mm, you can see here like the kernel forking has increased over the trend. Like initially it's quite low and now the growth is increased. Like many members are forking and using others' knowledge into the project, and which helps to increase the knowledge of both. And the number of forkings at 2024 is the highest, as 2025 is currently going on. I think like the 2025 will have the most, as it's crossed like around 55% over the half a year. And the most favorite notebooks we are like most forked notebooks are like here one is Ifra and many top like quick generate your SVG and PyTorch exercises and etc. And these are average forks per kernel and growth rate like we can calculate it by how many forks and unique fork count and unique forks and by each year. And similarly as how dataset has shown, like the for this the competition is MetaKaggle Hackathon. So like it's linked to that hackathon, and like we it will be also having a trend which is similar to like uh, datasets only. And there are many types of rewards in competitions like USD. Some competitions gives jobs, wax, knowledge, etc. The mainly used competitions are like USD competitions and knowledge based and file based. Mm, so the first is like USD, which is the top. Like the competition increases, and so the like as USD offers, USD means like dollars. Like as it is a monetary price, the kernels for that competition will be relatively higher. You can also see the average length of the kernel for competition. Like if the competition is of 1 month, like the kernel's average, like around 400 lines, 500 lines, like that. Over the time, like the kernel length decreases as less members use those competitions. And you can see the main trend here, like this negative implies the after deadline and before deadline. Like the 30 days before deadline, the like the kernels created are like uh, one third of the uh, kernels created on deadline. Like when the deadline is there, the kernels are created at the most like three times the normal, like 30 days before the competition, before the end of the competition. And here you can see like the kernel two here, like normal kernel versions, and here the unique kernels. Like the competitions will be the same, but the here kernels like here all kernel versions increase and competitions are the like number of kernels created in a particular year and number of competitions are there in that particular year. This stays the same, like the number of competitions, whereas the blue line, whereas the unique kernels, um, here are somewhat less compared to here, which is a huge peak. This shows there are many kernels which are forked and etc. And this is a why, because like this shows the um, month and year heat map, which is a different view other than this trends line plot. So I've just to see like how it looks and etc. And these are the host segments, like number of kernels created per particular host segments. Like I will show it in the competitions again, like types of competitions, like analytical, community, feature, getting started, playground, and recruitment, research, etc. And this concludes the notebook 3. And next we'll go into the notebook 4. We turned our attention to notebook episodes, discrete gameplay or interactive sessions within Kaggle competition. These episodes provide a granular insight into how agents perform, learn, and evolve. uh, Episodes are most prevalent in reinforcement learning style competition. We filtered our data into one competition, GRF, which is a Google Research Football with Manchester City in the bottom of the notebook. Uh, Now let us see this overall setup and how we have imported our basic libraries and dataset, and think of each episode as a game or stimulation match. Every agent that plays in the match is recorded in agent.csv. So each row in agent.csv equals to one submissions participant in episode. This helps track how each model performs, gains or losses, rating, and evolves. Mm, Now here you can see the types of episodes and the competitions where we the episodes the competitions in which episodes are used. There are around 24 competitions, 25 competitions. Like till yesterday it's 24, now it's 25, like newly added again. Let us see like the 20 here the 25 competitions listed here. Mhm. And uh, the types host segment types are of four types, like in which episodes are used: the community, featured, getting started, in playground. And and the organizations which created these episodic competitions are these four episodes, like mainly Kaggle, Google Research, Lux AI, and Federation International Researches, FI, Fed. And now you can see from 2022 to 2025, the reinforcement style episodic competitions have been created. At initial, they have launched six competitions, and recently they have launched one at 2025, and this is latestly added. And now the episodes created over time, like in these competitions, there will be episodes created for the submissions, like around 2000, in between 2020 and 2021. And now it is average duration in seconds, and number of episodes count is near 5 into 10 power 6 uh, on 2021. And now we will analyze agents also. Like this episode agent is a large data set of 16 GB, which is one third of the whole data MetaKaggle data set of 42 GB. And now here you can see the unique states and unique submission, how many number of unique submissions ID, and unique rewards. Like the reward is between, sorry, the states are of four states: two, three, four, five. and unique index as 0123. And we will here we are taking a unique competition, like our main case study centered on Google research football competition where agents played a stimulated football game and learned strategy behavior over time. Uh, the competition ID of that Manchester City, the Google Research Football is 2173. So we have filtered the competition ID and those episodes using the competition ID for both episodes and episode agent CSV files. And we have tracked how many episodes were submitted each day, peak often, and aligned with leaderboard refreshes or nearing deadlines. Like you can see the spine plot, like you can see like the near deadline, the more competition episodes are run, and you can see like agent distribution reward over the weekend, like score distribution by day revealed interesting patterns, like like all are median near zero, like because some have 100 and now weekly scores, like the 40th week is the competition started at 28th September 20 and ended on December 11th. So like the 40th week to 49th week, the scores are represented using the regional plot, and you can see the average episodic duration over time decreased. This uh, says like represents that the during initial time, like the episodes took larger time, which says like they are more complex and the episodes are not, the agent is not able to understand like where to go and of his goal state and end state, like it took more time, whereas at the end the episode, like the agent took least time and it became a much more robust and this good agent. Now we will go through like submissions and episode link, and you can see like the episodes are over like 5 lakhs and the submission is around 1400 around overall that period. And you can see the public and private schools. In here, plotting public scores over time really reveals the community's learning cover. Uh, link and the type submission score distribution by episodes, like I have told like two types of episodes are there, right? Type 1 and type 4. Like I have explicitly don't know like exactly what are these type 1 and type 4, but these are the two types. And the average public score trend, this shows the public score at the end is highest, like the average is highest at the end because the more competition, like participants learn how to do and what are the better steps to implement this competition, and the highest over the all time like is around 1750, and this is the highest public score distribution by week for that competition, like GRF competition. Uh, these are the by week, like what is the range and this violent plot. And this concludes the agents and episodes. Now I will show you the fifth notebook, which is mainly focused on tags, the label of recognition, like which dataset or competition kernel are most popular, like which tag, by which tag it is popular, and well-known tags which are used. Initially, like we have set up the environment and data set. Here, beyond data and code, Kaggle drives on discussion forums are where knowledge is shared, problems are solved, and ideas take root. Like in Kaggle, there are discussion forums, and etc. Now there are forms.csv and topics.csv. Mm, and next, like this shows the cumulative and not cumulative, like the number of forms and topics created over each year. Uh, like uh, like the peak is around 2021, where Kaggle is most popular in discussion related things. Like the more experts and reach Kaggle and talk stuff and related to this. And like there is also like upvote here is there, right? Like that also, there are upvotes and stuff in forums also. Like the highest score is like around 18,000 and the lowest is minus 256, which represent the form is very bad, or the it is like spam or etc. Here I have seen like the form with higher score reply. Like what is the main reply like for that form? Like thank you very much. Like as it is good form, like and the score is good. Like the replies are like the thank you and it is a good form. Like good discussion here. And next, like forum messages, hopes like the votes and reactions, which are main like thank you and these are main output, like main recognition for a form. And these are the count like reaction types, reactions present on the form. Like thank you is the highest among all the reactions which is present. And over the year, like the reactions are recently started around 2024. And the I have made an animated bar chart, so it looks good. Like for like the thank you is highest as I mentioned. And now, like, we'll deep dive into the tags. Like, tags are language of Kaggle. They help categorize the content across notebooks, dataset, models, and competitions. And are the parent tags is like around 830 tags across the Kaggle. Like these are like websites, research, search engines. Like these help to categorize the which topic that the particular dataset or a notebook goes into. And these are kernel tags. Like these in this we have like kernel id and tag id. Tag id is particularly like uh, reference it to the tags csv, and kernel id is reference it to the um, kernel id is reference it to the kernels. Now first, like we will analyze the all for notebooks. We will see like the top tags over the year. Like I have created an animated chart for this also, like from 2015 to 2025. You can see like the this animation goes into like recently the data visualization is looks like more, and data visualization notebooks are quite popular because it gives a more in-depth and correct analysis. And I have these topics, like these main top six topics are there, right? Top six tags which are used in notebooks. I have compared it with Google Trends. Like Google Trends, I have taken interest over the whole Google and the Kaggle percentage have drawn like in Google, data visualization searches are around 4491, and whereas in this like 302 3023 kernels are present. Like this shows that like more Google share and is relates the more Kaggle share in kernels. Like generally, more number of people search in like data visualization notebooks in both Google and Kaggle. Like I have created a particular data set, like in from Google Trends, I have downloaded an Excel uh, for each of the particular, suppose like kernels. There are like quite a number of CSVs which uh, week and etc. Like how many count interest like members showed here. Like that, I have analyzed it for all. Like similarly, like I have analyzed it for the data sets also. Like data sets also, we have education, nature, computer science. Whereas at 2024, you can see like the business grows too high. Like business tag related data sets have more number of tags, like 9,267 tags are there. And here also this shows like 21.72, which is the highest in Google share and in Kaggle share also. And similarly for competitions, like there are three types of competitions, like tabular, images, and text. Generally, these like tabular competitions are initially quite high. Like tabular means like CSV, Excel, and etc. Like the Google share is also quite same for all the three. And similarly, the model tags. Models are created at 2023 and it's over the 3 years. Like you can see English and some more tags. And similarly, I have Google Share, Google Trends Graph. And now like organizations created across Kaggle. Like what are organizations present across the Kaggle? Like 1,026 organizations are signed up on Kaggle. And like over the years, like from 2016 to 2025, the peak is at 2024, like 225 organizations have joined the Kaggle for like uploading their model notebooks and using for competitions, etc. And you can see the like word cloud for the names, like organization names, like mainly AI looks more like which says that the mainly the AI and AI related organizations have mainly signed up upon on the Kaggle, and these are the like tile chart like names of the whole organization 1,000 this. It looks good, and we will get to know whole names, right? Like you can get to know here and which organization is this like. And next, like also we will go into like models, like we have loaded and analyzed the metadata from Kaggle models. These are the blueprint of intelligence. You can see like the frameworks which are used like backbone of these models. Like the count is more PyTorch. Like PyTorch is the main backbone, and distributions of PyTorch and how PyTorch is increased over the years. You can see here, like PyTorch is not quite large at the beginning, 2023. Like now, recently, the PyTorch and transformers, where transformers have increased like quite a lot in Kaggle models. You can see here also, and now the models created over time, like this should be at initial, like I have forgotten added it at the last of the notebook. The number of models created over the time at initially when the Kaggle opened the Kaggle models like this web 2023, like 190 models they have deployed here, and now at July 1st till date, like 858 models are there. Final segment, uh, we have ex- we have explored the MetaKaggle code, a structured view into how Kaggle notebooks have evolved over years, languages, libraries, and coding culture. Like Kaggle supports multi-programming languages, but the Python dominates here. Uh, we have analyzed language usage in the notebooks to revolve the coding preferences and trends. Like now, we have initial library setup and datasets, and these are the utility functions in the main this notebook, which are available on this notebook. This helps to join both the MetaKaggle and MetaKaggle dataset. Like in MetaKaggle, we have versions and kernels. Like this shows like kernel versions and kernel versions.csv and kernels.csv, which helps to locate like which notebook and the path of it using ID2 path and part 2 ID and etc. Now, if we give and get source by ID, like if we give an ID as 1000 and the 1000 ID notebook is this. The name is like SVM with PCA, like principal component analysis. And you can see here like SVM and PCA. PCA will be at the bottom, like generally. Now, language trends like language script ID 8 is Python notebook. Around you can see like more a topic occupies the 80% of the whole. Like you can see here, the language ID is IPYNB. Uh, and you can see code analysis over the year, like in 2025, the around 1.1 million notebooks are created and etc. And when like now have created a data set where we have MetaKaggle code. In that code, we have like a huge number of data, like 5.97 millions. The location of path like the IPNBY notebooks, and suppose we need Python files, but in that R files is also there, and the location is quite difficult and time taking process. It's not difficult, I have to say, like it's time taking process, like it takes too much of a time. Like we have to analyze like around 6 million files. uh, so I have created a data set. I will update it like soon. So here we have suppose IPYNB path list. Like this gives the path list of all IPYNB notebooks which are present in MetaKaggle code. And similarly with for R files and Python scripts, R scripts and Python scripts. And now we have I have presently like path scripts I have defined like paths of each file. And now if we have like you by utility function get source, if we have path, if we mention the path, we'll get the whole utility whole code of that function, whole code of that Python IPVNB file. And now uh, around 5.4 million notebook files are present, and similarly 260K Python files and 100K R markdown files, and rest are like R and others. And first we will analyze like Python files, notebook files like IP by NB, and I have said like max is like 5 million, right? 5.4 million, which is a huge number. Like it takes too much of a time and it's need lot of computation. So I have took a 100K first 100K like first random 100K and have analyzed those files and stored in the respective data frames, and get got the top 15 libraries which are used in IPv4, which are NumPy and Pandas, these are the main libraries which are used like for basic computation and etc. And rest are like random, sklearn and everything. And remaining for R, similarly for R, I have done like R is around like 111, 112K, which is okay, like 12,000 extra files. So like highest is ggplot, which is for plots, and random forest is also used, rread for reading and strings, etc. Now for Python files, there is a major like sklearn is like mainly highly used. Like it is due to like many members are using like PBA files for automation and stuff. So the main are using like ML automation related things, and this concludes our MetaKaggle code. And next will go into this contests and rewards. Like this is now we will analyze our final notebook that explores the heart of the Kaggle, the competitions. We analyze who is hosting, how prices evolved, how user behavior shift near deadline, and etc. And here first the mainly like similarly like importing the necessary libraries and data. Like we can see like unique host segments, like types of like number of types of competitions. Like recently hackathons also added. Uh, Analytics, community, featured, getting started, playground, recruitment, and research. Each have their own benefits and their interests, and all are like good. And like communities of highest with 9,135, and the overall competitions happened till date are 9,817. Um, it will cross 10K within a few days, I think. I hope so. Uh, and next, like the computation per host segments, like this has a huge gap between these um, community and recruitment. You can see like more than. So like now reward types in competition, like there are 8 types of rewards, unique rewards. Like now euros, pounds, jobs, knowledge, kiddos, prizes, swags, and dollars. And like euros and pounds are like only one competition each, which are very few, matlab, less with respect to others. And jobs also less number of competitions, around 20. And knowledge and USD competitions are more, like as it is like money. And USD. Now you can see number of reward competitions like in each over the years, like how many competitions happen. And generally uh, in community competitions, there some values are null also in this. Like so that's why this count is too less here. Like generally 518 USD like monetary competitions happen till date. And this shows like various host segment and evolution of competitions over the years. And now breakdown of USD competitions, like these competitions grow for a few years. And like the peak went around, like reward went around 4.64 million, and last year like around like 7 million the overall competitions. Like many good competitions, like we can see here. Like now recently also too many good competitions like ERC prize, which with more number of money, and Gamma 3 3N challenge, and Kunsky, and etc. And now submission behavior analysis. Now you can see like number of submissions over the year and the post versus pre-deadline. Like you can see like deadline, like before deadline and after deadline, the how these notebooks they are submitting and the competitions they are submitting. And now team formation is also one of the main thing, like how the teams are formed in for the competitions. Like the number of teams formed also increased over a few years, and the peak has reached around 2021. And the average team size is around like 1.15, like means maximum members are appearing solo or with a group of two. And this concludes the seventh notebook. Now this is our write-up which we have submitted in the competition, unraveling the unfortunately ocean of Kaggle and Odyssey for datasets about datasets. Uh, the MetaKaggle data and MetaKaggle code have an extinguished repository of bytes of data and blocks of code. The study, our study consists of 41 CSV files with and 5.97 millions of code. Um, and this MetaKaggle data is keep on updating, which is a dynamic data which keeps on updating daily or weekly. Till now, there are 1,800 plus versions available. It studies various facets of MetaKaggle data visualization, uh, kernel versions, models, dataset, tags, teams, user achievements, um, and we have our exploration of MetaKaggle dataset reveals the rich, evolving dynamics of Kaggle ecosystem, from user growth, dataset trends to computation behaviors and model development. Each insights uncover how the community contributes to advancing machine learning and AI practices. Uh, this study highlights Kaggle is not just a platform but a living data-driven narration of AI progress. We have discovered significant growth in user participation, dataset creation, and collaboration competition strategies over a year. Like recently, hackathons are created in Kaggle, and many types of host segments are present. Notable trends shown: increased adoption of deep learning models, rising team sizes, sharp data line driven spike in submissions. Heartful thanks to Kaggle for providing an open, rich ecosystem that fuels data exploration, collaboration, and innovation. This journey through MetaKaggle has revealed not just data but a story of uh, ML community. We are grateful for this opportunity to learn, contribute, and grow alongside this incredible platform. Thank you. And resources will be shared in the description. Thank you.